This lesson is about graphing square root and cube root functions. So we'll start with our parent functions. We have the parent function for the square root, f of x equals the square root of x. Please note that it is not plus or minus. And then for our cube root function, f of x equals the cube root of x. So when we graph y equals the square root of x, and it's not plus or minus, you can make a table, x and y, and we know we can't take the square root of anything negative, so for anything negative, y doesn't exist. If we have 0, square root of 0 is 0. If x is 1, the square root of 1 is 1. The next perfect square in line would be 4, so I'm going to skip up to 4, and the square root of 4 is 2. And then the next perfect square is 9, and the square root of 9 is 3. And we call these the home base points. So if you know where these points are, then you can just translate those points whenever you do translating of your graph. And if you know the relationship between having 0, 0, 1, 1, 2, 3, 4, 2, and then going over 5, 6, 7, 8, 9, 3, that relationship of going over 1 up 1 and then over 3 up 2 and then over 5 and up 3, that relationship, if that, you can keep that the same as you do your translations. The other parent function we have is f of x equals the cube root of x. If we were to make a table for that one, we can take cube roots of negative numbers. So we'll start with negative 8. The cubed root of negative 8 is negative 2. The next perfect cube would be negative 1 because the cubed root of that is negative 1. Cubed root of 0 is 0. Cubed root of 1 is 1. And then the next perfect cube is positive 8, and the cube root of 8 is 2. Those are going to be our home base points for the cube root functions. When you graph those, it looks like a big stretched out S, because in the middle you have 0, 0, and then you have 1, 1, a negative 1, negative 1. And then you have, if we were to be counting, let's see, I'm going to have to squeeze this in, 2, 3, 4, 5, 6, 7, 8, 2. And 2, 3, 4, 5, 6, 7, negative 8, negative 2. It looks like this. And so those are the points that you're going to keep in mind as you translate these around. Now another important thing you need to think about is the domain and range of each of these. And I know I've kind of made a mess out of this. I've tried to keep it color-coded. But the domain of the square root of x is all of the x's from 0 on up. Starts at 0, so hard bracket on the 0, and then goes out forever. The range on the square root of x, also positive numbers, starts at 0 and goes on to infinity. So we have a limited domain and range for the square roots. For cubed roots, though, the domain, it's going on forever in both directions. So all real numbers are negative infinity to infinity. And then the range is the same thing. It's going down slowly, but it's always going down, and it's also always going up. So the range is also all real numbers. So now, for any radical function, and I mean this to be square root, cube root, or whatever, our for y equals plus or minus a, and then the square root, and then we have x minus h, and then plus k after the radical. Just like we've done for all our other functions, the negative is going to reflect it over the x-axis. The a will be your stretch or shrink. The h is your horizontal shift, and note that it's minus h, so it goes the opposite direction. And the plus k, the k is your vertical shift. Alright, let's do some examples now. The first one we have is f of x equals the square root of x minus 1 plus 3. So we know what the parent function looks like, and then we're going to take that parent function and we're going to shift it to the right 1 unit and up 3. So when you graph it, it looks like this. As you can see, all of our home base points, 0, 0 moved right 1 and up 3, 1, 1 moved right 1 and up 3, 4, 2 moved right 1 and up 3. So our domain on this depends on the endpoint here. The domain is now going to actually start at 1 and inclusive. Sorry about the bell. To infinity, and then the range. See, the domain starts here and then moves that way. The range starts here. starts at 3 inclusive and goes on to infinity. Our next example is f of x equals the cubed root of x plus 4. So that's going to take our cubed root parent function and it's going to shift the entire thing up 4 units, and it will look like this. So it's just the S-curve that we drew before, but all of your points 0, 0 went up 4, 1, 1 went up 4, and so on. Everything just shifted up 4 units. The domain on this is all real numbers because it's still going from negative infinity to infinity. And the range on this is also all real numbers. So on the cube root function, the domain and range didn't get changed. Alright, our next example, f of x equals 2 square roots of x. So this 2 in front of the function is going to give it a vertical stretch of 2 units, and it will look like this. This one looks the same as the parent function, only 1, 1 is now at 1, 2, and 4, 2 is now twice as tall at 4, 4, and so on. So all of your y values got multiplied by 2. It's stretched by a factor of 2. The domain for this, it still starts at 0, so 0 to infinity, and the range for this also starts at 0, 0 to infinity. Okay, next example is f of x equals, in parentheses, x plus 2, all raised to the 1/3 power, and then minus 3. And now, as you guys know, that 1/3 power means the exact same thing as cubed root of x plus 2 minus 3. So that's the same parent function. I just wrote it a different way just to see if you could recognize it. And then we have plus 2 inside, so that means we're going to go left 2 units. And we have a minus 3 at the outside, so that means we're going to shift it down 3 units. And it'll look like this, where the 0, 0 has gone left 2 units and down 3, and all the other points have as well. The domain and range on this one are still going to be all real numbers, negative infinity to infinity, for both domain and range. And by the way, I apologize for the crudeness of these graphs on this video. I had beautiful ones and I uploaded them, and I guess the file size was too big and YouTube didn't want it. So, you know, blame them. I apologize again for the crappiness of these drawings. For this example, we have negative, and then we have in parentheses x plus 1 to the 1/2 power, and then we have a plus 5. So that means that we're taking the square root of x plus 1, and this negative is on the outside, and then we have plus 5. So the negative is going to reflect it over the x-axis, the plus 1 is going to shift it to the left 1 unit, and the plus 5 is going to shift it up 5 units. And it will look like this. So the reflection turns it from this kind of curve to this kind of curve, basically flips it over the x-axis. The plus 1 then shifts it all, so 0, 0 goes to the left 1 unit, and then plus 5 up 5. And so then this point up to here, and so on. Our domain, the x's start at negative 1 inclusive and go on infinitely, and our range, this time the lowest y value we have is negative infinity, and the highest y value we have is up here at 5 inclusive. And my last example for you, f of x equals the negative cubed root of x and then minus 1. So this negative is going to reflect it over the x-axis. It's not going to have a horizontal shift, but it will shift vertically down 1 unit. And it will end up looking like this. So the S-curve that you had before is now backwards. Instead of looking like an S or, well, stretched out S, it now has reflected, and it's the other way. And then we just shifted the whole thing down 1 from where it was before. And that's it. So our domain here is going to be negative infinity to positive infinity, and the range, same thing, negative infinity to positive infinity. And that's it for today. We will continue working on this in class when I see you tomorrow. So you guys have a great evening, and enjoy my funny joke. Look, it's the kind of math you guys did on your last test. Ha ha ha. Just kidding. See you tomorrow. Love you.